Motors require varying amounts of current during startup and operation. When a motor starts, it draws a high surge of current to overcome the inertia of its rotating parts. This can damage the electrical system if not controlled. Disconnects provide overcurrent protection by breaking the circuit in case of overloads or short circuits. Motor starters perform the following functions. Firstly, limit the startup current surge. Secondly, provide overcurrent protection. And thirdly, allow for smooth acceleration and deceleration. Motors that require a starter typically have high startup current in relation to their operating current. Factors that determine the need for a starter include horsepower, type of load, and voltage. High horsepower motors generally require starters due to their high startup current. Motors driving heavy loads such as compressors and pumps need starters to handle the increased startup torque. Motors connected to low voltage systems such as 110 volts may require starters due to higher startup currents. Motors that do not require a starter can simply use a disconnect switch for overcurrent protection. These motors typically have low startup current and are suitable for light loads such as fans and small pumps. To determine if a motor needs a starter, consult the motor specifications such as its horsepower, voltage, and load type. Most manufacturers provide guidance on the need for a starter in their documentation or technical support. The high inrush current during motor starting can cause voltage dips in the electrical system, affecting other equipment. Starters mitigate this by gradually increasing the voltage applied to the motor. There are several types of motor starters available, each with its own characteristics and applications. Firstly, across-the-line starters, which apply full voltage to the motor terminals immediately. These are the simplest and most economical type, but result in the highest inrush current. Secondly, reduced voltage starters, which limit the initial voltage applied to the motor, thereby reducing the inrush current. These include auto-transformer starters, part-winding starters, and Y-delta starters. Thirdly, soft starters, which use solid-state devices to gradually increase the voltage applied to the motor. They provide smooth acceleration and deceleration and offer advanced protection features. And finally, variable frequency drives or volts, which control both the voltage and frequency applied to the motor. They offer the most precise control over motor speed and torque and can significantly reduce energy consumption. When selecting a motor starter, consider the following factors. Firstly, the motor's horsepower and voltage rating. Secondly, the type of load the motor is driving. And thirdly, the characteristics of the electrical system. Also consider the frequency of starts and stops and the desired level of control and protection. Disconnect switches are typically used for smaller motors that do not require reduced voltage starting. They provide a means of safely disconnecting the motor from the power supply for maintenance or repairs. Disconnects should be sized appropriately for the motor's full load current and must be capable of interrupting the motor's locked rotor current. In addition to overcurrent protection, motor starters often provide other protection features, such as overload protection, undervoltage protection, and phase loss protection. Overload protection protects the motor from overheating due to excessive current draw. Undervoltage protection prevents the motor from restarting automatically after a power outage, which could damage the motor or driven equipment. Phase loss protection protects the motor from damage due to a loss of one or more phases of the power supply. When installing a motor starter or disconnect, always follow the manufacturer's instructions and local electrical codes. Ensure that all connections are tight and that the equipment is properly grounded. Regular maintenance is essential to ensure the reliable operation of motor starters and disconnects. This includes inspecting contacts, terminals, and wiring for signs of wear or damage and tightening any loose connections. It's also crucial to verify that the overcurrent protection devices are properly sized and functioning correctly. Remember that working with electrical equipment can be dangerous. Always de-energize the circuit before performing any maintenance or repairs. If you're not comfortable working with electricity, consult a qualified electrician. Consider the motor's service factor when determining the need for a starter. The service factor indicates the motor's ability to handle occasional overloads. Motors with a higher service factor may be able to tolerate higher startup currents without a starter. Examine a motor's nameplate for information about its locked rotor amps or LRA. This value represents the current the motor draws when it's initially energized. If the LRA is significantly higher than the motor's full load amps or FLA, a starter may be required to limit the inrush current. Motors used in critical applications, such as fire pumps or life support systems, typically require starters to ensure reliable operation. These starters often include redundant components and advanced monitoring features. Energy-efficient motors, also known as premium efficiency motors, may have lower startup currents than standard efficiency motors. This is because they are designed with improved materials and construction techniques to reduce losses. In some cases, energy-efficient motors may not require a starter, even if they have a relatively high horsepower rating. The National Electrical Code or NEC provides guidelines for selecting and installing motor starters and disconnects. Consult the NEC for specific requirements related to overcurrent protection, grounding, and wiring methods. Consider the ambient temperature in the motor's environment when selecting a starter. High ambient temperatures can reduce the starter's capacity and may require derriting. Motors that operate in hazardous locations, such as areas with flammable gases or dust, require special starters and disconnects that are designed to prevent explosions. These starters are typically enclosed in explosion-proof housings and are certified for use in specific hazardous locations. Before installing a motor starter or disconnect, conduct a thorough arc flash hazard analysis to determine the potential for arc flash event. This analysis will help you select the appropriate personal protective equipment or PPE and establish safe work practices. It's also important to train personnel on the proper operation and maintenance of motor starters and disconnects. This training should include topics such as electrical safety, troubleshooting, and preventive maintenance. When replacing a motor starter, be sure to select a replacement that is compatible with the motor's voltage, horsepower, and load requirements. Using an incorrect starter can damage the motor or create a safety hazard. Regularly inspect motor starters for signs of overheating, such as discolored wiring or melted components. Overheating can indicate a problem with the starter or the motor. Consider using a motor management relay or MMR to monitor the motor's performance and provide early warning of potential problems. MMRS can detect overloads, underloads, voltage imbalances, and other abnormal conditions. The type of enclosure used for a motor starter or disconnect depends on the environmental conditions. Enclosures are available in various materials such as steel, stainless steel, and fiberglass, and are rated for different levels of protection against dust, water, and corrosion. When selecting an enclosure, consider factors such as the ambient temperature, humidity, and exposure to corrosive substances. If a motor starter fails, troubleshoot the circuit to identify the cause of the failure. Common causes of starter failures include overloads, short circuits, and component failures. Before replacing any components, be sure to disconnect the power supply and verify that the circuit is de-energized. When selecting a motor starter, consider the availability of spare parts. It's important to choose a starter from a reputable manufacturer that offers a wide range of replacement parts. This will ensure that you can quickly repair the starter if it fails. Consider the long-term cost of ownership when selecting a motor starter. While a less expensive starter may seem appealing initially, it may have a shorter lifespan or require more frequent maintenance. A higher quality starter may be more expensive upfront but can save you money in the long run. If you're unsure about which type of motor starter or disconnect is appropriate for your application, consult a qualified electrical engineer or electrician. They can assess your specific needs and recommend the best solution. Remember that electrical safety is paramount when working with motors and motor control equipment. Always follow safe work practices and consult the NEC for specific requirements. Different types of loads place different demands on motors during startup. For example, centrifugal pumps and fans typically require less starting torque than positive displacement pumps or compressors. The load's inertia also affects the starting current. Higher inertia loads require more energy to accelerate, resulting in higher starting currents. The frequency of starts and stops can also influence the choice of motor starter. Frequent starts and stops can cause excessive wear and tear on the motor and starter, requiring a more robust starter design. Consider using a soft starter or Voltst for applications with frequent starts and stops. These starters provide smooth acceleration and deceleration, reducing stress in the motor and starter components. The power company may have specific requirements for motor starting, particularly for large motors. These requirements may include limitations on the inrush current or the use of power factor correction equipment. Consult with the power company to ensure that your motor installation complies with their requirements. In some cases, it may be necessary to use a reactor or other impedance device to limit the inrush current during motor starting. Reactors are typically used for large motors or in applications where voltage dips are concerned. Power factor correction capacitors can improve the power factor of the electrical system, reducing energy losses and improving voltage regulation. Power factor correction is often required for large motor installations. The location of the motor starter can also affect its performance. Starters should be installed in a clean, dry, and well-ventilated area. Avoid installing starters in areas with high temperatures, humidity, or corrosive substances. The wiring between the motor starter and the motor should be sized appropriately for the motor's full load current. Undersized wiring can cause voltage drops and overheating. Use the appropriate wiring method and conduit for the application. The grounding system should be properly installed and maintained to ensure electrical safety. Grounding provides a path for fault current to flow back to the source, tripping the overcurrent protection device. Regularly inspect the grounding system for corrosion or damage. Consider using a surge suppressor to protect the motor starter from voltage transients. Voltage transients can damage electronic components and cause starter failures. Surge suppressors are typically installed at the main power panel or at the starter itself. The size and type of surge suppressor should be selected based on the expected voltage transients. When troubleshooting a motor starter, start by checking the power supply. Verify that the voltage is correct and that there are no blown fuses or tripped circuit breakers. Next, check the control circuit for any open circuits or shorts. Use a multimeter to measure the voltage and continuity of the control circuit components. If the motor starter is equipped with overload relays, check to see if they have tripped. Overload relays are designed to protect the motor from overheating due to excessive current draw. If the overload relays have tripped, determine the cause of the overload before resetting them. If the motor starter is equipped with a magnetic contactor, check the contactor contacts for wear or damage. Worn or damaged contacts can cause the motor to run erratically or fail to start. Replace the contactor if the contacts are severely worn or damaged. If the motor starter is equipped with the solid-state overload relay, check the relay's settings and calibration. Solid-state overload relays can be programmed to trip at different current levels and trip times. Verify that the relay settings are appropriate for the motor and load. If the motor starter is equipped with a Voltst, check the Voltst's parameters and settings. Voltsts can be programmed to control the motor's speed, torque, and acceleration. Verify that the Voltst's parameters are set correctly for the application. When replacing a motor starter component, be sure to use a genuine replacement part from the manufacturer. Using a non-genuine replacement part can void the starter's warranty and may not provide the same level of performance or reliability. Regularly inspect the motor starter's enclosure for signs of damage or corrosion. Damaged or corroded enclosures can compromise the starter's protection against dust, water, and other contaminants. Repair or replace the enclosure as needed. Consider using a remote monitoring system to monitor the motor starter's performance and provide alerts in case of problems. Remote monitoring systems can track parameters such as voltage, current, temperature, and vibration. This information can be used to identify potential problems before they cause a failure. When decommissioning a motor starter, be sure to disconnect the power supply and remove all wiring. Dispose of the starter properly in accordance with local regulations. Before working on any electrical equipment, always follow lockout/tagout procedures to ensure that the equipment is de-energized and cannot be accidentally energized. Lockout/tagout procedures involve placing a lock and tag on the power disconnect switch to prevent it from being turned on. Train all personnel on the proper lockout/tagout procedures. Regularly review and update the lockout/tagout procedures to ensure that they are effective and up to date. Consider using a motor starter with built-in diagnostic capabilities. These starters can provide information about the motor's performance and identify potential problems before they cause a failure. The diagnostic information can be accessed through a local display or a remote monitoring system. When selecting a motor starter, consider the environmental impact of the starter's components and materials. Choose starters that are made from environmentally friendly materials and that are designed for easy recycling. Dispose of used motor starters properly in accordance with local regulations. Some components, such as capacitors and batteries, may require special handling. Consider using a motor starter with energy-saving features such as automatic energy optimization. Automatic energy optimization adjusts the motor's voltage and frequency to minimize energy consumption. This can save energy and reduce operating costs. Regularly clean the motor starter's enclosure to remove dust and dirt. Dust and dirt can insulate components and cause them to overheat. Use a vacuum cleaner or a soft brush to clean the enclosure. Avoid using compressed air, as this can spread dust and dirt throughout the enclosure. When inspecting a motor starter, check for any signs of rodent or insect infestation. Rodents and insects can damage wiring and components. If you find evidence of infestation, take steps to eliminate the pests and prevent them from returning. Consider using a motor starter with a conformal coating on the circuit boards. Conformal coatings protect the circuit boards from moisture, dust, and corrosion. This can extend the starter's lifespan and improve its reliability. When selecting a motor starter, consider the level of technical support that is available from the manufacturer. Choose a manufacturer that offers comprehensive technical support, including documentation, training, and troubleshooting assistance. Regularly back up the motor starter's configuration data. This will allow you to quickly restore the starter's settings if it fails or needs to be replaced. Store the backup data in a safe and secure location. Consider using a motor starter with built-in communication capabilities, such as Ethernet or Modbus. This will allow you to integrate the starter into a larger automation system and monitor its performance remotely. When selecting a motor starter, consider the ease of installation and maintenance. Choose a starter that is easy to install, wire, and maintain. This will save time and reduce labor costs. Regularly calibrate the motor starter's overload relays. This will ensure that the relays are accurately protecting the motor from overloads. Follow the manufacturer's instructions for calibrating the overload relays. Consider using a motor starter with built-in harmonic filtering. Harmonic filtering reduces the level of harmonic distortion in the electrical system. This can improve the performance of other equipment and reduce energy losses. When selecting a motor starter, consider the level of surge protection that is provided. Choose a starter that is equipped with adequate surge protection to protect the components from voltage transients. Regularly inspect the motor starter's wiring for loose connections. Loose connections can cause overheating and voltage drops. Tighten any loose connections using the proper torque. Consider using a motor starter with built-in power monitoring. Power monitoring provides information about the motor's energy consumption, power factor, and other electrical parameters. This information can be used to optimize the motor's performance and reduce energy costs. When selecting a motor starter, consider the level of safety features that are included. Choose a starter that is equipped with safety features such as door interlocks, emergency stop buttons, and ground fault protection. Regularly inspect the motor starter's cooling fans. Cooling fans are used to dissipate heat and prevent the starter from overheating. Replace any damaged or malfunctioning cooling fans. Consider using a motor starter with built-in predictive maintenance capabilities. Predictive maintenance uses data analysis to identify potential problems before they cause a failure. This can reduce downtime and maintenance costs.